Hello everyone, welcome back to our Generative AI series. In the previous lecture, we took our LangChain based resume analyzer and started converting it into a LangGraph workflow. We created our state, converted our existing function into nodes, connected them using edges, compiled the graph, and executed the workflow. We also saw how the states move through the workflow. So it will going from the extract resume, retrieve jobs, and analyze our resume. So but our workflow so far was still mostly sequential. So and this is where things become interesting. What if the resume score is too low? Instead of simply ending the workflow, we want our application to make a decision, improve the resume, and the analyze it again. So our workflow now needs something that we haven't implemented yet. Conditional routing and cycles. The workflow should be able to say if the resume scores is good enough, stop the flow. Otherwise, improve the resume and analyze it again. This changes workflow from a simple sequence into a dynamic state flow workflow. So in this lecture, we'll implement exactly that. So let's continue building our resume analyzer and see how LangGraph handle decisions, loops, and state changes in real application. Let's get started. In the previous video, we created this basic LangGraph workflow. The resume is first extracted, then we retrieved matched jobs, and finally we analyzed the resume. At this point, our workflow is completely sequential. But now let's introduce a real decision into the workflow. So this is our sequential flow. Now new is this is the decision flow or real decision into the workflow. When we are analyzing resume, after that we need to check that scores. If a score is greater than or equal to 7, we are going to end our flow. If suppose that score is less than 7, then we need to improve our resume. When we are going to improve our resume, it is going back to the analyze resume phase. So it is going to analyze that resume. So it will analyze again and it will improve that, and then it will go for check score. So this flow will again come into a picture. So that's why we are going to improve it iteratively. This is introducing two important LangGraph concepts. One is conditional routing and another is cycles. So we'll go into the VS Code and we'll see how we can implement it. So for implementing it, we need to add the score in our code base. So we need to store the score somewhere since LangGraph passes state between nodes. So we will add the score to our resume state. So we'll go to the state.py file. Yeah, so if we'll see here, we added score and improvement count. We'll discuss about improvement count after few minutes. So we added the score, that is a float one, and then here we are taking the score and improvement count for the print statement. So here we added the score in the state.py file. Then we need to initialize this state. So for that we'll need to improve the resume service.py file. So here we added that score. This is the initial state. Okay, so whenever a new resume will enter in our application, we need to initialize these state values. So similarly, we need to add it for the score. So we added the score over here in the initial state. So this initial state contains an empty score. When it will be coming initially, it is going to contain the empty score, and after when it will go for the analyze resume, it will be improved and it will have some data. This is the only change we need in the resume service.py file, because in the initial state we need to store our score. That's why we need to update our resume service.py file. Then next we need to go for the notes.py, and whoever is not able to recall it, they need to go back to the previous video and you can get the content from there, what is the flow and how it is working. Here we are just improving our existing flow. So in the notes.py file, our analyze CA resume node will already calling the LLM. If we'll go and see here, analyze resume node is this is calling the LLM model, right? So it is already calling the LLM model, and LLM will give us the analysis, and it will include the scores as well. So now we need to save that score back into the LangGraph state. So if we are getting the scores, we need to save it. So we are doing this, and we are saving that score to the LangGraph nodes. Sorry, back into the LangGraph states. Now the score becomes part of the shared state, and it will be moving from one node to another node, and it can be accessed by the next part of our workflow. Okay, and after that we need to create the score based routing functions. So for that we have written check resume score. So here we have a score and improvement count as well. So if resume is good enough, it means if that score is greater than or equal to 70, it means our score is good enough and we are moving into the end. But if suppose if that is less than, then it means we are not going for the end. It means we need an improvement here. So if we are going for the improvement count, it means infinite times we cannot go for the improvement. Suppose if that resume will not reach till 70, it means we need more API calls and it will take our more tokens. So that's why we need to stop it at some point of time. So that's why we added our condition improvement count greater than equal to 2. So if we'll reach this one, we are not going to improve our resume. So maximum improvement attempt reached, moving to end. So when maximum attempt will be reached, it will going to be the end. Now if that improvement count is not 2, then it is going for the improvement. So score is below 70, moving to improve resume, and from here we are going to return the improve. Its only responsibility is to make a routing decision. So whether it need to route for the end of the flow or it need to improve the process. So this is only for the routing decisions, and this is, we can say it as a routing function. So it doesn't need any graph node. Okay, then after that we need add conditional is in the workflow.py file, because how workflow.py will remember these things. So for that we added a conditional edges over here. So analyze resume, if we'll see, it means this argument tells LangGraph where the decision start. So our decision will start from the analyze resume, and then check resume score means this will tell that LangGraph to which function should make the decision. So here we will have a function check resume score which is going to make a decision. So just now we saw we have a check resume score where we have this conditions, right? So this function is going to make the decision whether we need to end that loop or we need to continue that part. So and these arguments map the result of that function to the next destinations. If we are going to check resume score, whether it will be going to in or it is going to improve our resume. So these are the two conditions which we have written inside the check resume score. So whether it is going to int or it is going to improve our resume. Then we need to create a improvement node, right? We need a node because we are going to introduce a one new method that is called as a improve resume node. So for that we added a node over here, and we have a method here improve resume node in the nodes.py file. We created this node because we are using a separate LLM operation for improvement, and the first LLM operation analyze the resume, the second LLM operation improve the resume. So we are separating these responsibilities. Now we need to add the cycle as well. So for that we add the edges. So from improve resume it will go for the analyze resume, because we are going back to the analyze resume. So we added a edge from improve resume to the analyze resume, and this is our cycle. So first we'll analyze our resume, then it will check the scores. After checking the score, it will improve our resume or it will end the flow. If it is going to improve our resume, again it will go for the analyze resume, it will check the score. So this is the our cycle, it is moving into the loop, and this is difficult to represent as a simple linear chains. But In graph, it is very simple or easy to implement. For implementing this, we imported check resume score improved resume node to the workflow.py file, and now we'll go for the improved resume node. So if we'll see here again we are calling the LLM model. So here we are going to improve our resume with LLM, and for that we are passing the resume text and improvements. What are the improvements or suggestions needed? It is going to pass it that. In the improved resume node, we are going to call the LLM model again. And for notes.py, we imported analyze resume with LLM and improve resume with LLM. And in our resume prompt.py file, we added one more prompt for the LLM, right? So improve resume prompt, which we already saw. In the resume.prompt file, we added improve resume prompt. So here we added it because this is the another prompt for improving the resume. So we mentioned it over here. You are a professional resume improvement assistant. Improve the following resume based on the identified improvement suggestions. Current resume improvement suggestions will be there, and rewrite the resume while preserving the candidate's original information, because we don't want to modify the original information, just like as name, LinkedIn profile, etc. So do not invent companies, job title, skills, experience, education and achievements. And if we want to add more, we can add it over here. Then return only the improved resume text. Okay, so this is the prompt we are using for the improved resume prompt. And in the LLM service.py file, how we created for the analyze resume with LLM, similar way we created it for the improved resume with LLM. So here we are getting the resume text and improvement suggestions in the form of list, and then we are invoking the LLM models and we are going to get the informations, right? So till now we already converted our sequential flow into a dynamic workflow. This is our a new workflow, right? It will start, then it will extract the resume. After extracting resume, we'll go for the retrieving the job from the API. Then it will analyze resume. After analyzing, we are going to check the score. If score is greater than 70, we are going to end that flow. If that score is less than 70, we are going to improve our resume, and then we'll analyze resume and check our score. It means if our score is less than 70, we are going back from improved resume to the analyze resume flow. So this is the iterative process we are going to follow over here. And this is the workflow. If we'll see, we have a state, we extracted that resume, we added some extra text, and we retrieve that job. When matched jobs is getting added, after that we are going to analyze this resume and our scores got added, right? And when scores got added, we need to check that score whether that is below 70 or above 70, and according to that we'll end the process or improve that flow, right? So according to that we are going to analyze it again. So here what is the main difference here in the LangChain and LangGraph is LangChain and LangGraph are not competing technologies in this implementation. They are not competing each other over here. So they solve a different kind of problems or different parts of the problem. So LangChain will handle the LLM related operations, where LangGraph handle the workflow orchestrations, right? So they are following some different kind of works, right? So they are not competing each other. LangChain build the LLM operations, and LangGraph will connect those operations together and maintain the states, make decisions, and create cycles and control the executions. So that's why LangChain and LangGraph can work together. Okay, they are not competitor for each other. And with that, we have successfully implemented our cyclic LangGraph workflow. In the next lecture, we'll learn about AI agents. Until next time, keep learning, keep growing, and keep building. And I'll see you in the next lecture. Thank you.